Dear students, in the previous session, we discussed about quantitative data analysis with specific focus on descriptive statistics. In fact, how descriptive statistics helps a researcher to analyze the data, to report the data. One of the limitation of descriptive statistics is that it cannot be used for drawing generalization or drawing conclusion or testing hypothesis. For this, we need to utilize the inferential statistics. And this session we will discuss on different inferential statistics for data analysis and reporting. And you know that research always conducted on sample, and sample is a small section of the population. Sample is a representative section of a population. We do research on sample, but we need to draw conclusion about the population. So, you just imagine we have a sample of 2000 students, but you have population of 20,000 students. You have to draw conclusion, you have to draw inference about the populations from studying the sample. And how it can be done? But it is possible we can draw inference or generalization with certain probability about the population. For this, we need to understand, we need to utilize inferential statistics. So, what is inferential statistics? So, there are number of statistics or statistical measures that is included under inferential statistics. So, I can say the very purpose of inferential statistics is to draw conclusion, to draw generalization, to draw inference about the population on the basis of sample data. Inferential statistics are useful for testing null hypothesis. You know that null hypothesis is very important for quantitative research like experimental research, like correlational studies, like a survey kind of research. So, you cannot test or verify null hypothesis without use of inferential statistics. So, therefore, inferential statistics are useful. And the third point I want to tell you here that inferential statistics are always based on probability, I think the normal probabilities. So, inferential statistics are of two types. One is parametric statistics, another is a non-parametric statistics. Both kinds of statistics has its implication, has its use for research context. Statistics can be parametric or can be non-parametric, depends on certain assumptions. When certain assumptions are fulfilled, then we use parametric statistics. When certain assumptions are not fulfilled or met, we use non-parametric statistics. Besides this, to use which statistic, parametric or non-parametric, it all depends on our purpose of the research study, the type of hypothesis we formulated and the variable that we are studying. Let us now discuss the parametric statistics. So, let me start with examples. Very popular statistics or very widely used parametric statistics are t-test. You know, in case of t-test, you compare two means. You can find out the significant difference between two means. When you use ANOVA, the F test, you can compare the significant difference between and among multiple means, more than two means, and therefore, you can have a ANCOVA. ANCOVA you can also use it. So, under parametric statistics, the well known statistics are t-test, ANOVA and ANCOVA. Then what are the basic assumptions we should keep in mind when we are using parametric statistics? The first assumption is that the data must be normally distributed, because I said these inferential statistics are based on the probability, and especially the parametric statistics must be used when data is normally distributed. And I hope that you have studied the normal distribution, the bell-shaped distribution that is symmetrical, that have a very symmetrical to the mean. So, that normal distribution must be kept in mind when you are thinking of using parametric statistic. I mean, your data must be normally distributed. Not only normality of the data is important, there are other requirements are there. Other key requirements are your data must have homogeneity of variances. You have studied in descriptive statistics, like variances. When you are comparing two groups or multiple groups, each group should be having a similar or homogeneity of variances. Then only you can use parametric statistic. And another important point or requirement is that before using normality or before using parametric statistic, you should also see that your data are collected by using random sampling. Your data collection should be based on the probability sampling, and that must be the random sampling, so that your data can be independent observation. Whatever data you have collected from the field, these are independent, not due to something else. So, the requirements must be fulfilled before you use parametric statistics, like normality of data, homogeneity of variance and independence of observation. And besides this, when you talk about parametric test and parametric statistics, you should also keep in mind the kinds of measurements or the kinds of data you have. I am talking about whether your data is in interval scale or ratio scale or ordinal scale. If your data is in ordinal scale, nominal scale, you cannot use parametric statistics. But when your data is interval scale, when your data is ratio scale, so you can use parametric statistics. Now, let us see the t-test is a very important parametric statistics. It is widely used parametric statistic because this is the statistic that can gives idea about the significant difference between two means. T-test is used when you want to determine there is a significant difference between the two means or two groups. For example, you have collected data from boys and girls about their students' achievements. Now, you want to draw inference whether boys are better or girls are better in the performance, whether the difference between boys' achievement and girls' achievement is significant or it is due to some sampling fluctuation or some kind of error. So, it can be done by using t-test. In case of t-test, you compare the two means and then the result indicates that whether the difference between two means is significant or not. Then sometimes the question may be coming in your mind, what is the significant? Significant, I mean that must be statistically significant. For example, your boys mean is 34 and the girls means is 30. The difference is 4 only. Whether this difference of 4 is due to chance factor or it is a real difference, this can be answered by using a t-test which indicate that whether this 4 is really significant or it is due to the factor like a gender difference or it is due to the some chance. So, t-tests are mostly useful in experimental studies. It is mostly useful in a case of like a survey research, when the researcher interested to compare two means or two groups. There are different types of t-tests are also there. You can have a independent t-test. I think independent t-test means you have boys, you have girls, you want to compare their means, they are independent. You want to compare the rural and urban students, they are independent. So, in this case you use the independent t-test, but there is another kind of t-test to use, paired t-test. The paired t-test means like when you collect data from the same individual more than once. Here what is paired? The individual is the same, but you are conducting test or collecting data many times. They are paired. For example, in case of experiment, you select the sample and conduct the pre-test, then you give intervention and afterwards you collect the post-test. You conduct the post-test and collect the data in the post-test. So, what here happening, the individuals are same, but you are conducting test more than one time, and therefore, they are called paired group, they are paired test. So, in this case you have to use t-test, but that is called a paired t-test, and this paired t-test mostly used in a experimental studies or when you collect data from the same individual, but in multiple occasions, in multiple times. So, on basis of t-test you can draw inference or you can verify your hypothesis. For example, if you had a hypothesis, there is no significant difference in achievement of boys and girls. So, on basis of t-test you can verify it. If your t-test result is significant, then your null hypothesis is rejected. When your null hypothesis is rejected, then there is a significant difference. This is not due to the chance, but this is due to gender differences. And the next kind of inferential statistic is ANOVA, and usually we say analysis of variance. I say this is a, sometimes some people say the F test. So, very powerful higher order statistics researcher use for quantitative data analysis. The difference between t test and F test is like in case of t test you can compare only two groups at a time, but in F test or ANOVA you can compare more than two groups at a time. So, therefore, sometimes people say ANOVA extends the t test by comparing means across 3 or more groups. So, when you have only two groups to compare, you use the t test, but when you want to compare more than two groups, like you have a rural, you have a urban, you have a tribal, at a time you want to compare, then the best statistic is ANOVA. ANOVA or F test gives the result on which you can say whether there exists a significant difference in the means of 3 groups or more than 3 groups. And the key assumption you have to keep in mind when you are using ANOVA or F test is that the data must be normally distributed, data must be collected by using random sampling method, and there must be equality of variances. And in case of ANOVA, you can have a one-way ANOVA. One-way ANOVA, just I have given example, rural, urban, tribal. So, these are only three groups are there and this is one way ANOVA. Only one condition on which you want to compare them. The student's achievement is one way, but the groups are three and you want to compare them. So, you can go for a ANOVA analysis or F test analysis. On basis of this, you can determine or find out whether any significant difference exists. If ANOVA test says there is a significant difference exists among these three groups, then you have to go for a post hoc analysis. Post hoc analysis means you go for a paired comparison, rural urban, then urban tribal, rural tribal. So, then multiple comparison you have to make and find out what is the significant difference exists, whether it is rural urban or rural tribal or urban tribal. So, for this you have to go for a post hoc analysis, that is another statistical procedure. This is similar to t-test. And one question always comes in the mind of the researcher and research scholars is that how to interpret this t-test and f-test. And I should tell you that the t-test and f-test can be calculated manually or it can also be calculated by using a computer software like your Excel, SPSS, CSAT, that can be used. I will tell you that how you can interpret the t-test and f-test results. Your t value or f value, sometimes we say the critical value or critical ratio. This is one point you have to identify, and then you have to identify the p value, and this p value usually if you are calculating t-test and f-test by using any statistical software, then you will find out the p value. P value means this is a probability value. What is the probability value? That is already automatically the statistics software they calculated and give us. And then one point we have to keep in mind is the level of significance. This is something probability, level of probability. I told you at the beginning of my discussion, inferential statistic always based on the probability, because something is significant at some probability level, something is not significant at some probability level. So, probability is very important in case of inference, because statistic itself is not certain, it is always probable. If this mean is 35 now, if you conducted test and find out mean is 35, and this is also probable. Maybe after 1 hour you conduct the test, you may get some different mean. So, therefore, always we have to go for a probability, and we have a level of significance. We have a 99% probability and we have another like a 95% probability. And in level of significance we say 0.001, this is a 99% probability, or 0.05 is a 95% probability. So, level of significance here is only 001, means only 1% chance is that it may your statistics may be wrong, and 005 means 5% probability that your statistic or your calculation may be wrong. So, these are the points, level of significance, critical value, probability value you have to keep in mind, and accordingly you have to interpret t-test and f-test. I will give you example like when your p value is 0.00. So, that means your t or f-test is significant, because this p probability is 0 means there is 0 error. Data statistic is telling like here there is 0 error and therefore, it is a significant. But you see when your probability value is 0.57, 0.57 means there is a possibility of there is a error here. 0.57 means 57% error is there. So, when p value is 000, then blindly you can accept it, the t or f test is significant. But when the p value is more than 0.05, I think it is more than 0.05, then your t value or f value is not significant. So, that way you can interpret the T and F tests. Okay. And similarly, there is a non-parametric statistics. I told you one is a parametric statistic, we discuss T test and F test, and we have another statistic that is a non-parametric statistics. So, non-parametric statistics, it is also based on certain assumptions, and I said in the beginning of this discussion, parametric statistic, there certain assumptions are there, and non-parametric statistics, certain assumptions are there. Now, let me tell you what are the assumptions. Like when these assumptions are fulfilled, you can go for a non-parametric statistics, or in which condition, which situation we can go for a non-parametric statistics. But I should tell you that the parametric statistical analysis are more robust, strong, it gives more accurate, reliable result than non-parametric statistics. But in some cases where researcher cannot use parametric statistic, so you do not have any other option, you have to go for a non-parametric statistic. Parametric statistics are always distribution free. Like in a non-parametric statistic, they say distribution is normally distributed, but in case of non-parametric statistics, distributions are free. It is not binding, your data will conform to the probability, normal probabilities. In case of parametric statistic, your data must be distributed normally, but in non-parametric statistic you want to use, but your data is not normally distributed, do not worry for this, because the non-parametric test based on the distribution free, I mean your data may not be normally distributed, and therefore, it is distribution free. And the second kind of point we should keep in mind is that the types of measurement or types of data. In case of parametric test, we use ratio data and interval data, but in case of non-parametric test, we can use ordinal data, or even some cases we can use nominal data. So, here the data type is flexible, it is not necessary we have to wait for, or we have to use when data is interval or in a ratio scale. I mean with ordinal scale rank data, we can also use non-parametric tests. And when you say that some kind of outliers are there in our data, when outlier extreme scores are there, then it is not wise to use parametric tests, rather we have to use non-parametric test, or in a straight line I can say this non-parametric test will be more robust, more useful when outliers are present in the data. The examples of non-parametric statistics are like chi-square test, Mann-Whitney U test, Wilson sign rank test, Kuskal-Wallis test. There are a variety of non-parametric tests are there. It all depends upon the researcher and objectives and his research question and variables, types of data, and then the researcher can choose anyone. So, let me explain you, there are many non-parametric tests are there, but let me tell you Mann-Whitney U test. Here what it do, this compares the median of two independent groups. You say in case of T test we compare the means of two groups, but Mann-Whitney test we compare the median of two independent groups. So, when like independent T test is not useful, or we cannot use because of violation of the assumptions, so we can come to the Mann-Whitney U test. Similarly, we can have a Wilson sign rank test. Here also it compares the median of paired samples, but T test we can have a independent T test, we can have a paired T test, but in a non-parametric test or data analysis, we have a separate test, Wilson sign rank test, where you can paired or you can compare two medians. And we have Kruskal-Wallis test, it is very similar to ANOVA, but in ANOVA there are certain conditions are there. When these conditions are not fulfilled, you can use the Kruskal-Wallis test. Here mean is not a point to comparison. So, here median is the point of comparison. So, we can use Kruskal-Wallis test in place of ANOVA. Similarly, just I also told you, earlier my session, like a product moment correlation, rank different correlation. So, the product moment correlation means you have to use parametric, but in a rank different correlation. Suppose you want to find out the significance of the correlation. If you want to find out significance of the product moment correlation, you have to use parametric statistics. If you want to find out the significance of the rank correlation, then you have to use non-parametric statistics. And there are the most widely the non-parametric test the researchers are using, the chi-square test. It is a very popular like a t-test. Most of the research scholar or majority of the research scholar they use chi-square because it is easy to understand and it is easy to calculate, easy to interpret, and therefore, we use chi-square test as a non-parametric test in many of the situations. In chi-square test, our data is mostly categorical data. Data is coming in terms of frequency, data is coming in terms of the number, and data sometimes it is coming in terms of percentage. So, that you want to compare. So, chi-square test is used to determine if there is a significant association between two categorical variables. Two categorical variable like you say like boys and girls, and they are giving opinion about maybe women empowerment. So, then boys and girls are categorical variable and you want to compare them here. You want to find out the association between these two categorical variable. So, here you can go for a chi-square test. So, unlike parametric test, the chi-square test does not require data to be normal distributed or variance to be equal. I told you chi-square, since it is a non-parametric test, it does not require normality of the data, it does not require the equality of variance. So, therefore, it is flexible. When the condition for parametric test are not fulfilled, so you can turn to chi-square or any kind of non-parametric statistics. In chi-square, especially chi-square, what happens? Chi-square it try to compare between the observed data and the observed data and one is the criterion data. Observed data means what? When you go to the field, you collect the data, that is the observed data, and you make a association between observed data what you observed and what the normality talk about, what the independency talk about, what the contingency talk about, or in other words, the chi-square has a three different types. One is chi-square test of normality, one is chi-square test of independence, another is chi-square test of contingency. So, these three types of chi-square can be calculated different way, but the basic principle is that chi-square try to find out the association between the observed data and the normality data, observed data and independent data, observed data and contingency data. Now, the question is, we have only one set of data, but we need another set of data, and this another set of data comes from normality, comes from independence, comes from contingency, and that as a researcher either manually if you have to provide by following formula, or if you are using any statistical software, the statistical software automatically will use and will give you the results. Let me give you one example here. This is a kind of research situation where there is a possibility of using chi-square. Suppose you ask one question, does mandatory attendance of students improves learning? So, you put this question to the maybe 40 students. 40 students you ask this question, or 40 boys students you ask this question and 40 girl students you ask the question. Does mandatory attendance improve the learning? And you have three options. I said this is sometimes in nominal data. You have three options. The student can say yes, student can say no, or student can say undecided, I cannot say. So, you have a boys group, you have a girls group. Boys group say yes 20, but the girls group say yes 16. Boys group say no 12, girls group say no 4. Boys group say undecided 8, girls say 10 undecided. Now, you see you have a two group category like boys and girls, but their opinion and response is different in terms of yes, no, undecided. Now, this is the question. Now, you want to determine whether the difference of response among boys and girls is significant, or it is due to chance, or it is due to some error factors. And if this is your question, the chi-square will help you. The chi-square will help you here by suggesting whether the responses between boys and girls is different, significant difference, or it is due to errors. So, if you can use the chi-square formula, either you can go for normality or independence, and if you can use the chi-square formula, the observed frequency, then your expected frequency, if you use the calculated formula, and the result will tell us whether it is significant or not significant. The same way, the way you interpret the parametric statistics like t-test and f-test, same way you can also interpret. When we are interpreting chi-square, you have to see the level of significance, because chi-square also depends on probability. You have to also see like your critical value or chi-square value, you have to see the p value, and accordingly you can take a decision whether chi-square is significant or not significant. Accordingly you can draw the conclusion. So, I have discussed briefly the parametric test and non-parametric test, and I also explain in which situation and which condition these parametric tests like t-test, f-test, non-parametric test like chi-square test are useful. So, as a researcher, we have to keep in mind like when we have quantitative data, and we have to think of which kind of statistics are most suitable, whether parametric or non-parametric. But parametric, if you want to use, you have to see the conditions, the assumptions, all the assumptions must be fulfilled before using the parametric statistics. But when these conditions are not fulfilled, you have another option, non-parametric statistic. But again I also want to tell you that first we have to try to use parametric statistic, because it gives the more robust and reliable results. And when we are not able to use parametric statistic, then we can come to the non-parametric statistic like chi-square, chi-square value, depending upon our comparison or depending upon our research objectives or hypothesis, we can use it. But our first preference must be on parametric statistic, second can be on the non-parametric statistics. So, I hope that you have understood the parametric and non-parametric statistic, t-test, f-test and chi-square, and you can now use these tests for your research data analysis and preparing the reports. Thank you.